Imagine a world where you could create anything you can imagine. Not with traditional tools, but with a device that builds objects layer by layer from the bottom up. This is the world of 3D printing, a technology that has revolutionized manufacturing and design. What started as a niche technology in the 1980s has blossomed into a global phenomenon. 3D printing, also known as additive manufacturing, has become a driving force in innovation across various industries. The journey of 3D printing is a testament to human ingenuity and our relentless pursuit of pushing technological boundaries. From its humble beginnings to its current widespread adoption, 3D printing has consistently exceeded expectations. This essay will delve into the captivating history of 3D printing, exploring its evolution from a rudimentary technology to a transformative tool. We will trace its path from the pioneering inventions of the 1980s through the advancements of each decade. We will uncover how 3D printing has revolutionized fields like medicine and aerospace. Join me as we embark on this journey to understand how 3D printing is reshaping our world. The 1980s marked the dawn of 3D printing. In 1981, Hideo Kodama from Nagoya Municipal Industrial Research Institute developed a groundbreaking approach to rapid prototyping. His method used a photosensitive resin that solidified when exposed to UV light. Although his patent application was never completed, Kodama's work laid the groundwork for what we now know as stereolithography. 3 years later, in 1984, Charles Hull, an engineer at UVP Inc., filed his own patent for stereolithography. Hull's invention, the SLA-1, became the first commercially available 3D printer. The SLA-1 used a focused UV laser to cure a liquid photopolymer resin, building objects layer by layer. This revolutionary technology was initially limited to industrial applications. It was primarily used for rapid prototyping, allowing engineers to quickly create models and test designs. However, the potential of 3D printing was clear from the start. It promised a future where complex designs could be manufactured with ease. The 1990s witnessed significant advancements in 3D printing, but the technology was still in its infancy. New 3D printing processes emerged, including fused deposition modeling, FDM, and selective laser sintering, SLS. FDM, developed by S. Scott Crump, used a thermoplastic filament extruded through a heated nozzle to build objects. SLS, on the other hand, used a laser to fuse powdered materials like nylon and metal. These advancements expanded the range of materials that could be used in 3D printing. They also improved the speed and accuracy of the printing process. However, 3D printers remained expensive and complex. They were primarily used by large corporations and research institutions. Despite the limitations, the 1990s saw 3D printing gain traction in industries like automotive and aerospace. Engineers used 3D printing to create prototypes and custom tooling, speeding up the design and manufacturing process. The seeds of 3D printing's potential were beginning to sprout. The 21st century ushered in a new era for 3D printing. The convergence of several factors, including technological advancements, decreasing costs, and the rise of open-source hardware and software, made 3D printing accessible to a wider audience. Desktop 3D printers became a reality, empowering hobbyists, educators, and small businesses to embrace this transformative technology. The open-source movement played a crucial role in democratizing 3D printing. Projects like RepRap, an initiative to create a self-replicating 3D printer, fostered a vibrant community of makers and innovators. This collaborative spirit led to the development of affordable and user-friendly 3D printers. As 3D printing became more accessible, its applications expanded beyond prototyping. Makers started using 3D printers to create custom gadgets, tools, and even art. The possibilities seemed endless, limited only by imagination. The medical field has been one of the greatest beneficiaries of 3D printing's transformative power. 3D printing has revolutionized the creation of prosthetics, offering customized solutions that are more comfortable and functional than traditional prosthetics. Patients can now receive prosthetics that are tailored to their specific needs and anatomy, improving their quality of life. Beyond prosthetics, 3D printing is being used to create anatomical models for surgical planning. Surgeons can use these models to visualize complex procedures and practice delicate operations, reducing risks and improving outcomes. 3D printing is also being explored for creating implants and even bioprinting organs. Bioprinting, a cutting-edge application of 3D printing, involves using bioinks to create functional tissues and organs. This technology holds immense promise for addressing organ shortages and revolutionizing regenerative medicine. The aerospace industry has also embraced 3D printing for its ability to create lightweight and complex components. 3D printing allows engineers to design and manufacture parts with intricate geometries that would be impossible to create using traditional methods. This has led to the development of lighter and more efficient aircraft and spacecraft. 3D printing is also being used to create tools and equipment for astronauts in space. The International Space Station is now equipped with a 3D printer, allowing astronauts to manufacture tools and spare parts on demand. This reduces the need to transport materials from Earth, saving costs and increasing efficiency. Looking further into the future, 3D printing is expected to play a crucial role in space exploration. It could be used to build habitats on the Moon or Mars, utilizing local resources to create structures that protect astronauts from the harsh environments. 3D printing is no longer confined to industrial settings and research labs. It has found its way into homes, schools, and even libraries, empowering individuals to embrace their creativity and solve everyday problems. 3D printers are being used to create everything from custom phone cases to personalized kitchen gadgets. In education, 3D printing is fostering a new generation of creators and innovators. Students are using 3D printers to design and build prototypes, bringing their ideas to life. 3D printing is also being used to create educational models, making learning more engaging and interactive. As 3D printing technology continues to evolve and become more affordable, its impact on everyday life will only continue to grow. We can expect to see 3D printers become as commonplace as computers and smartphones, empowering individuals to customize their world and solve problems in new and innovative ways. The future of 3D printing is brimming with possibilities. As materials science advances, we can expect to see 3D printers capable of printing with a wider range of materials, including biomaterials, composites, and even food. This will open up new frontiers in fields like medicine, construction, and even culinary arts. In space exploration, 3D printing will play a pivotal role in establishing a sustained human presence beyond Earth. It will be used to create habitats, manufacture tools and equipment, and even produce food, utilizing local resources to minimize dependence on Earth. 3D printing could also be used to create custom medical devices and implants for astronauts, ensuring their health and well-being in challenging environments. The development of 4D printing, a technology that allows 3D printed objects to change shape or properties in response to external stimuli, holds even more exciting possibilities. Imagine 3D printed structures that can self-assemble, repair themselves, or adapt to changing environmental conditions. The potential applications of 4D printing are vast and still being explored. As 3D printing becomes increasingly powerful and accessible, it is crucial to consider the ethical implications of this transformative technology. The ability to create objects on demand raises concerns about intellectual property, counterfeiting, and the potential misuse of 3D printed objects. It is essential to establish clear guidelines and regulations surrounding the use of 3D printing to ensure responsible innovation. Open dialogue and collaboration between governments, industry leaders, and the 3D printing community are crucial to address these ethical considerations and mitigate potential risks. Education and awareness play a vital role in fostering responsible use of 3D printing technology. By promoting ethical practices and encouraging critical thinking about the potential impact of 3D printing, we can harness its power for good and create a future where this technology benefits all of humanity. From its humble beginnings in the 1980s to its current status as a transformative technology, 3D printing has come a long way. It has revolutionized industries, empowered individuals, and opened up new frontiers in science and technology. The journey of 3D printing is a testament to human ingenuity and our relentless pursuit of pushing technological boundaries. As 3D printing technology continues to evolve, its impact on our world will only become more profound. We can expect to see 3D printing integrated into every aspect of our lives, from the products we use to the homes we live in. The possibilities are limited only by our imagination and our commitment to responsible innovation. The future of 3D printing is bright, filled with opportunities to solve global challenges, improve lives, and explore new frontiers. By embracing this technology with a sense of responsibility and a spirit of collaboration, we can harness its power to create a better future for all.